So hello guys and welcome back to my YouTube channel. In today's video we shall be looking at how you can build a production ready rack system. Alright, so building a rack system is not just enough, but building a rack system that you can actually deploy on the cloud, and then your clients can actually make use of it, and then their customers can make inference on it. Okay, so we shall be looking at how you can build a production ready rack system. So one of the things you need to look at while building a production ready rack system is your vector store. Okay, instead of having your ChromaDB locally on your system, you're going to be working with a cloud storage. Okay, so because you can't use a local storage for deployment. So we're going to be working with Chroma Cloud. Okay, ChromaDB has a cloud storage for um, ChromaDB where you can build your vector store. You can also build this on render if you are deploy your ChromaDB on render if you are deploying on render or any VPS. Okay, so but we're going to be working with Chroma Cloud. So how do you do this? Okay, so just head over to trychroma.com. So when you get to trychroma.com, create an account and sign in. All right, I've created an account and I've signed in. It's very straightforward. So when you create an account and sign in, you're going to create a database. So when you click this button, create a database, you're going to create a database and then give your database a name. I already have a database here called ChromaDB. So this is the database I'll be using for this project. All right, so the next thing you need to do is to head over to API key, and then you need to create an API key. Click here to create an API key. I've created one, so I have this API key. I'm working with this API key. So copy your API key if you create it, and then you also copy your tenant ID. So these are the three details you'll be needing from your Chroma Cloud, okay, from the trychroma.com. All right, so once you have all this, you're going to save them in your requirement.txt. You save your Chroma API key and your tenant, your Chroma tenant. All right, so these are the two values you have to set. So to work on this, there are various libraries you need to install for this project. So these are all the different libraries you'll be needing, ranging from the more ETA tool to IPython. For the Jupyter notebook, you need to install Pydantic and then Pydantic settings. So we're using Pydantic setting to read the environment variables. Is more dynamic. So you install LangChain core, you install LangChain, you install LangChain test splitter, you install LangChain community, LangChain Chroma, LangChain Hugging Face, LangChain Grok, LangGraph. You need to install ChromaDB, Sentence Transformer, PyPDF, Fast API, and Yovicon. So all these libraries are all you need to install. All right. So once you are done installing them, you click over to start implementing the project. It's very straightforward. All right. So the first thing is to initialize your environment variables. Okay. So we are working with Pydantic settings. We're using Pydantic setting to read the environment variable. So from Pydantic setting, you import base setting and setting config dig. Okay. So you'll be creating a class settings and then it will be inheriting base setting. All right. So then now you need to set up the different keys that are inside your environment variable. So in my environment variable, I have ChromaDB, I have Chroma API key, I have Chroma tenant, and I have Grok API key. All right, I said this, and all of them are string, so that my environment variable will read them as string. All right, then this is my model config, which is the setting config, and I pass my file. So I have .env on my base directly where I have all my environment variables. And then I need to create an instance of setting, which is settings is equals to setting. So once you've done this, then you can easily pick these values by just saying setting.chroma API key, setting.tenant, setting.grok API key, and then it's very straightforward and easy. So we'll have to run this code now. All right, so this is done now. So let's set up um vector store and embedding model. Okay, so we need to import ChromaDB. We need to from LangChain Chroma, we need to import Chroma, and then from LangChain Hugging Face, we need to import Hugging Face embedding. All right. So we need to first of all create the tenant, the Chroma client. Okay, so the Chroma client is from ChromaDB.Cloud client. We'll pass the API key, we'll pass the tenant, and we'll pass the database. Okay, so which is setting.chroma API key, setting.tenant, and then remember our database is ChromaDB. So with this, we've created our client from the Chroma crowd. Okay, then we'll create our embedding model from Hugging Face embedding. We'll pass the model name, which is BGE based EMV 1.5, and then we're working with the CPU. So we pass the model quacks, okay, which is device CPU. And then we'll now create the vector store, which is from Chroma. Remember, this Chroma is coming from line chain Chroma, all right? We'll pass the collection name, which is the production ready rag, embedding function, which is the embedding model, and then we'll pass the client. So once we run this and this established, we already have our vector store. Then we can actually add documents to this and also run similarity search. So we'll have to run this, and then it's going to take a little time to run. So this is where we implement our embedding. Okay, so it's also pretty straightforward, the embedding here. All right, so we create the part where our PDF file is. So I have my PDF file here from PDF novatech.pdf. All right, so and then I need to create the loader. I'm reading this PDF file from the PyPDF loader, which is gotten from the LangChain community.document loader. All right, so we'll now pass loader.pypdf loader will pass the path, then it's going to load, and then we'll now load the pages. So this will actually load all the pages and return a list of documents. So each document contains each page. Okay. All right. So we are going to run this cell now. All right. So now let's look at the pages that it's got. So we got 1, 2, 3, 4, 5, 6. These are 6 pages. Okay. So these are the pages. We got the first page, second page, and then we'll have the metadata and then the page content. Okay, we'll have the page number 1, 2, 3, 4, 5, 6. So if I print the first page, the content in the first page, okay, this is the length of the content here. So now when we look at the content in the first page, so let me pick the first page. So dot page content. So if we print this, you see that there are a lot of text here, all right? And here now, when I printed the length, you see that we'll have up to 1,440 tokens. Okay, so but our the embedded model we're working with can only handle 512 token at a time. So that's the maximum token it can handle. So we're going to split this so that we ensure that the content of each document like this is not more than what the embedded model can handle. Okay, so we now have this. We are importing the recursive character text splitter from the line chain text splitter. Okay, and we are creating our splitter. Okay, we are setting the chunk size to 450. All right, so this is a good value, and then chunk size, and then the overlap 150, and then we create the separator. So this is our splitter, and then we are now going to split the documents. So when we split the documents, now you see that we'll have a larger number of documents, and if you look at their page label now, you see we have 111, 222, 3344. So it has to split each of the pages, and if I check the length of each of the pages now, it's not going to be more than what we passed at the chunk size. So if we now check document of one dot page content, so this is the content we have in the first document. So now let's have a look at the length now. Okay, so If we have a look at the length, you see what we have here, 377 tokens. All right, so it's actually not more than 450. So that's what we'll have here. So now we're going to embed these documents into our vector store. Okay, so we'll get the chunks, and then um, we are picking it chunk by chunk from the document. We are picking 10 at a time. Okay, so we're iterating the document. We're getting each batch. Each batch is around 10. So, and we are printing adding batch, and then vector store.add document. We're going to add the document to the vector store. So let's run this, and then we wait so that it can actually add the entire document to the vector store. All right, so the embedding is done. Then we need to look at the retriever. So the retriever is very straightforward. All right, so we're going to be using the similarity search. So here now, I'm using the asynchronous similarity search because I want to also be running asynchronous function in this because this is a production ready app. All right, so the documents to be retrieved first to await vector store that a similarity search, and we are passing the query. The query is how many days of leave do employers get, and then I need 5 chunks, and then we'll run this, and then it's going to retrieve the 5 chunks for us. So these are the 5 chunks that it retrieved from the vector store. All right, so this is just how it works. If I want to see I can iterate to get the all the chunks that was retrieved, which is this. Okay, this is the first one, this second one, this is the third one, fourth one, and then the fifth one. So these are the chunks are. Now let's build our RAG agent. So it's very straightforward. This is our prompt, very straightforward prompt. So we are building this for Nova Assist, an AI assistant for Nova Tech Solution. Okay, so Nova Tech Solution is a tech company, and then this is our prompt to guide the RAG agent both on how we should make the retrieval and then give the response. So we are importing this other couple of libraries. We're importing tools so that we can add decorator in our tools. We are importing the state graph, messages state, start and end. We are importing messages from launching code messages. We are importing the human message and system message. We are importing chat grok from launching grok. So, and LangGraph prebuilt, we are importing the two condition, two nodes, and then from ipython.display, we're importing the display and image so that we can actually see the graph when we are done. So first of all, we initialize the LLM. Okay, so from ChatGrok, the model we are using is OpenAI GPT-OSS 120B parameter model, and we're passing the API key from settings.grok API key. All right, then this is our retriever. Okay, so this is the doc string. Okay, this is a tool called to retrieve relevant content. Then what we'll have here now is it will be getting a query. So this is the query, which is the query to make the retriever. So very straightforward. The document is equals to vector store.similarity search. You make the query. So after the query, we iterated the content that it retrieved so that we can actually return only the content. Okay, so can return the content, and then we return the content. So that's what the retriever is doing. Then we'll build the tools. So the only tool we have here is this retriever, and then we'll bind the tool to the LLM. So which is this LLM with tool equals to LLM.bind tool. We'll pass the tools. Okay, now this is our assistant. So it's also an asynchronous function. Okay, so it's taking the message state and it will also return the message state. So what we need to do here is to construct the system message, and then we'll make we invoke our LLM using the LLM with two. Okay, a invoke for asynchronous invocation, and then we'll pass the input, which is we'll pass our system message, and then we'll pass our list of messages from the message state, and then we'll return the response. We'll take the response, and then we'll pass it. We update the state of the graph. So very straightforward. So now we can now build our graph here now. Okay, so create the builder from state graph, passing the message state as our state schema. Then we're adding two nodes. The first node is the two nodes, and the second node is this assistant. Okay, so we're going from start to assistant, Then from assistant, we are calling the tool condition. The tool condition is going to return tools or end. It's going to return tools whenever there is a tool call, and end when there is no tool call. Okay, so when there is a tool call, it goes from tool to assistant. That means the tool will return whatever it has back to the assistant. Then the assistant will have to process it. So here now we are compiling the graph. So we can run this, and we are going to see our graph below now. So this is the graph. This is how it looks like. So we are going to go over to now start invoking this graph. Okay, so very straightforward. Graph.invoke. We need to pass this await because this is an asynchronous function, and then we are passing the input, which is our human message. What we have here is who are you. All right, so let's look at this and then see the response from the graph. Okay, we did not run our system message. Okay, so I didn't run this particular part of the code, so I'm going to run this and then I'll run this again. All right, then let's run this now. All right, so we now have a response here. So we'll see that it's pretty straightforward. So the human message was who are you? Then the AI message returned the tool call. The tool now, the message was Nova Assistant, who are you? It now returns some data from the vector store, and then the AI was able to give us a response. Okay, that's pretty straightforward. So we can actually be streaming um, the response from the graph or from our agent as it's been executing, so we can be streaming it to see all the different steps, step by step, step by step. So that's what we are trying to do here now, trying to stream. We are streaming values to see all the different steps, and then we are printing each step, the message from each step. So now let's look at this. So this is the first step, the human message. The second step was okay, this was quite fast. The second step was the AI message. The third step was the retrieval message, and then the last step was the AI message. Okay, so how many days of leave do employers get? So which is what we actually have here now. So and it's very straightforward. So we can also stream this chunk by chunk, getting the retrieving the data chunk by chunk as they are coming. Okay, so that's what we did here now. So we are importing the AI message chunk, and then we are streaming messages. So as the messages are coming, we are streaming, and then we are flushing them down on the output. So we run this, we'll only be getting this output. So this was pretty fast, so, but it was actually streaming the response chunk by chunk as they were coming. All right, so this is just how the RAG works, and then we'll be able to get response from the RAG. So now the next thing now is we can't deploy a Jupyter notebook, so we're going to build a deployable file for this our project now. So what we're going to do is we'll go back to our code base. We're going to create a folder where we have all our source files, so src, and inside it we'll start creating all the files that we need. Okay, so src has the folder, and inside the folder we'll start creating all the files we need. First of all, this is the init.py. Okay, so I'm going to create the init.py. I'm going to create embedding.py. Okay, no, I don't need the embedding here because we've already done our embedding. So all we need the utils.py. All right, so we need the rag.py. Okay, and what other file are we going to need? All right, so let's start putting all our data where they should be so that we can create other files as we need them. So inside the util, we are going to have all the utility data we need, which include this from our pydantic. Okay, we'll need it here. Then all the data from our vector store, we also need it in the utils.py. So we'll have this on top. All right, so we'll have this here, and what else do we need? So no, we don't need the loading and then the test splitter. We don't need this, and the next file data we'll need is the prompt. So I can also pass the prompt at the util.py. Okay, I can also pass the prompt here. Okay, and then this is our agent. So we're going to have the agent at the rag.py. So we'll have the agent here at the rag.py. So now I'm going to go over this and import all other data from where they should be. We don't need this here. So what we need now is from src.utils. I need to import the settings and vector store and also the system prompt. Okay. So now inside the utils, I will also be initializing my LLM inside the utils. So this will be in the utils because it's also a utility file. So I will have it here, and then I'll need to take this there as well. Then I also need to now import the LLM here. All right. So I think that we're almost done with arranging our files the way we actually want them to be. So these are the util file. We are done with this. We'll save it. Okay, so this is the rack file. Now I'm going to go over it. I'm going to get this particular data down here. So I'm going to get this particular data down here. Okay, and then this is our graph. We build our graph, which is the graph here now. All right, so okay, so this is it. So this is actually what we'll have here, and what else do we need now? So I also need a function here now. I need a function for streaming the output, the response that we'll have here. So which is this function that we'll have here now. So we'll be needing this function. Okay, so I take this, and so this function will have to come in when streaming response okay, so this function will have to come in we want to stream the response. So um, I don't need this. No, I don't need all these things. So query is a string, and then it should also return a string. Yeah. So our message is equals to human message query, and we're going to paste what we got here now. So I'm going to arrange this code to actually work here. Okay. So I'm going to take out the query, and I need all this to be here. All right. So this is actually what we have here now. Okay. Okay, so this is what we have here now. We'll get the message, which is the human message. We're now iterating between the streaming. We're trying to get we are streaming we are streaming the messages, and then this is the output we are getting. So we need to import um, the AI message chunk. So yeah, so I think I've imported it now. So the AI message chunk is here now. Okay. Yeah, so we've imported the AI message chunk, and then instead of printing this, remember what we needed is this. This data we need to be getting. So instead of printing this, I'm going to yield it. So I'm going to yield this. So it's going to be yielding this particular output. So no, this should not be returning a string. So I'm going to be yielding this particular output. All right, so our streaming is actually done. So what we're going to do now is we're going to test what we've built so far and see that it's actually working. Okay, so to test it, so we're going to import this, say from src.rag import streaming response. Okay, so here now we're working with graph, and then the graph has been computed here, so we can go ahead to run this code. So it's going to take a while because it will need to run all the codes that we have here. Okay, so this is done now. So we are going to we're going to run this. So to run this now, so we need to execute from chunk in streaming response. We'll pass the query, and then we are trying to print the chunk. So remember that this thing returns, this stream response returns an kind of an iterator. So we're going to go over it and then print the response. So we're going to run this code. So as we can see, it was able to stream the response. So that means our agent is working accurately. Now that our code is inside this Python file now doesn't mean that we are ready. So we need to build an endpoint so that we can actually serve this to a front end. So we're going to create one more file here. So we're going to call it route. So router.py. So this is where we're going to build our endpoint. So from first API, import so API router. So we're going to import the API router, and so from src.rag we need to import the stream response. Okay, so we are going to run this. So we need to create the router. So the router is equals to API router. Okay, now we're going to pass the prefix. So the prefix is going to be chart, and then the tags will be charts as well. So we're going to now build a post request to stream this response to the output. Okay, so we're going to say at router the get. No, I want to build a post request. So So we're going to be streaming, all right, and then this will start from here, and then we'll create this file. So chat stream will be taking a query. So it takes a query and then it's going to stream this. So this is basically how it's going to run. It's very straightforward. Okay. So this is just a doc string that my copilot generated here. So what we are going to be doing here now is that it's going to be streaming our response. So, but it's not going to work like this. So we need to also import something from fast API. So I'm going to say from fast API the response, I'm going to import streaming response. Okay, so this is what we need to get. Then here now I'm going to be returning the streaming response. I'm going to be using, so this streaming response is what fast API uses to return a stream of data. Okay, and then this is the function I want to call, and then this is the argument the function takes, which is the query, and then the media type is text, plain text, text slash plain. So with this now, our route is completed. So, but we are not done yet. We still have one more thing to do. Okay, so which is building our main.py. Okay, so we're going to build our main.py. So this is our entry file to this code now. So this is the entry file. So when you watch, it's not inside SRC, it's on the base directory. So I'm going to say from fast API, import fast API. Okay, and then from SRC the router, import router. So app now is equals to fast API. App is equals to fast API. Okay, so this should be import. That was a mistake. And then I also have to now include my router into the app. So with this now, our app is going to run. Okay. So once I'm done with all this now, what I need to do now is to head over my terminal and then run this code now. So I open my terminal. So at my terminal now, I'm going to um, run this code now. Okay, so to run the code, we are using the command uvcon main app. Okay, reload. So what we have here is uvcon is the server to run this then main is our file, and then the app is the fast API app instance that we'll have here, and then reload is for auto reload. Then we're going to run this and it's going to start the server. So once it starts the server, we can actually view the Swagger UI and see how and then interact with our backend and see how it's working. So our application has started successfully. So we'll go over to the browser and then go to localhost port 8000 and docs to load our fast API app. So this is the Swagger UI, and then we have only one request, which is a post request. So we can actually try it out. Okay, so we can actually try. You see our doc string is here. So we can just pass the query here to just try this out. So the query is very straightforward. So we can go with who are you, and then we can execute and then wait for our response. Okay, so we see that we got a response now. All right, and then we can go further to say um, what does the company do? So and then we can execute this, and then we're able to get a response. So this is here now we'll have our rack system ready for deployment. So we can just take this file now and push it to GitHub and then deploy it on render thread. So um, thank you very much for watching this video. If you like what you watch, give us a thumbs up so that this wonderful video can get to more people. Subscribe to this YouTube channel and watch our other videos that we'll have. Thank you very much once more. Meanwhile, keep coding. See you in the next video.